Okay. So the other thing about running a conference and or giving a talk is you should always have an offline version of your slides available, which I do not. So what's probably going to have to happen here is while we sort this out, I'm going to have to give you this talk in a sort of from the back of my brain perspective, which is fine. So I don't want to download the update to this. Can you actually see this? Oh, great. Okay. So I've been doing Android since 2008. 2008 had a contest before the phones came out. President of touchlab, Android since 2008. There was a contest. There wasn't even a phone, which there were probably 50 to 100 people globally who were in this, which is kind of weird. I've been doing Java since 96. I've been programming since I was 7. When my mom taught me BASIC. That's my background. We also run this thing that is happening today, which is also why I didn't update these slides so much. I'm just kind of talking mostly. This is going to be a guide, then I'll get into it in more detail. We've run the big Android meetup. We run Droidcon NYC the past couple of years, and have partnered with SF with someone who's also here. Hi, and lots of talks, lots of videos, lots of things. Cool. So where to start? And I kind of was like, do you start with what or why? And it's because it's kind of an interesting thing until you really understand it in its depth. So what is Doppl? Doppl is Android-centric, I would say code sharing rather than cross-platform framework, because cross-platform is an ugly, ugly phrase that people don't like automatically if you build a lot of mobile, right? So it's based on J2objc. Do you know what J2objc is? It's Java to Objective-C. Cool. Very accurately named, but not super exciting. And it is tools basically to augment J2objc and then expanded Android runtime and common Android libraries. Java to Objective-C includes a JRE runtime and some Android, but when I say some, I mean like very little. So like text utils and a few other things, but a bunch of stuff is not in there. It's just code and not UI, which I think we believe is kind of where you should be. Trying to do a shared UI is usually disgusting, or at least not ideal. But converting Java to Objective-C always sounds horrible, right? And that's what we thought when we first tried it, and we didn't look at it for a long time. The person who made it, or at least started off or runs it, is Tom Ball. He was son, apparently through the start of Java, looking at his LinkedIn page, Google since 2008. James Gosling has left a glowing recommendation on this guy's page. So the point of this slide is this guy is legit, and he's super Java, super nerd, right? If you don't know who James Gosling is, then, well, don't worry about it, but he made Java. So J2objc is used by Google in these products, which are pretty high profile, right? And then here's a list of other things that use it. I mean, yes, there's one thing from Yahoo I saw in there, but everything else is like a nightmare of things you would never use and you've never heard of. And there are reasons, and it's because J2objc is very hard to use. The team avoids Gradle explicitly in their discussion groups. They avoid Android Studio. There's a J2objc Gradle project. It was not heavily supported. It is officially not supported now. The people that are working on it are out. And there were plenty of issues that I found with it. Setup is difficult, and Android support is shallow. There's no context, which we can get into whether context was a good design thing or not, but that's a different discussion. It exists. Enter Doppl, if you know what the picture's from, and the dragon. I was going to edit that out, but here it is. So expanded Android support. And what that is essentially is adding parts of Android context, because most popular Android libraries touch the context at some point to do certain things. So if you don't have that in there, you're basically taking them out of any possibility of using them. For example, before this, we were looking at Xamarin, which was kind of whatever, but then the Xamarin folks came in and pointed us to RoboVM, and RoboVM was kind of interesting, and they're like, oh, you can use all these libraries. You can use retrofit, and you could use nothing else, because everything required some more stuff that's specific to Android. And RoboVM was really, I thought it should be like, hey, build your Android application without affecting your Android development time, and then also then build your iOS parts. And that's not what they marketed it as. They marketed it as like, hey, person who's been doing Java Server for 20 years, you can make an iOS app now. And I thought that was totally the wrong argument. And then they got bought by Xamarin, and Xamarin got bought by Microsoft. And I said, wow, it'll be at most 6 months before they get shut down. And I was wrong by 5 months, because it was like gone in a month. So Anyway, we did the parts of the context. We did the SQLite Android database stack in this toolset. And again, you could argue about whether that's a good design, but that doesn't matter because it exists. Shared preferences, local file system, threading. So there's a sort of simulated version of looper, message queue, and handler also in this thing, essentially providing what you might consider a large portion of non-UI Android, and not including content provider and also the kind of stuff. Testing support. We've added some Doppl-specific annotations to support testing. Some JUnit runners that essentially, like if you're using Roboelectric, Roboelectric does a whole bunch of stuff, but in a lot of cases, what people really use is just provides a context for your tests, and that's kind of what we're doing to facilitate that. And the J2objc Gradle project and some other stuff using J2objc, you can run JUnit tests in the command line, but if you want to try to debug your JUnit tests running in Objective-C land, it's a nightmare. So we're facilitating doing visual debugging of your JUnit tests that are transpiled into Objective-C in Xcode visually. So that's part of the tool set. Common Android libraries currently existing, retrofit, JSON, Dagger, RX, Android, Event Bus, DBORMs, Green.io, Covered, Squeaky, which is a thing that I wrote, which is an annotation processing port of ORM Lite, which is also, I am the person who did the ORM Lite adapter for Android back when that happened. So if you loved it or hated it, if I had been hit by a bus before 2010, you would not be using it. So I'm that person, and I did the update. And then I gave a talk about that last year, why no one cares, because there's too many Android ORM databases, frameworks anyway. But those things exist. I did Commons, IO, and Lang, which, again, you could argue you probably shouldn't be putting in your Android apps. We had it, so whatever. Several thread queues, including our thread queue. There's a priority thread queue that Yeet from Google makes that also works in Doppl. Essentially a bunch of these things. Some of them have full unit test coverage. Some of them are still in that process. So retrofit's 100%. JSON's like 99.7, and I can tell you which unit tests are failing and why none of them really matter except one, and that's a long discussion. Dagger, I'm not really sure, but Dagger basically is like, it's like a pass-through. It's hard to explain. RxJava works, but there's one thing that we'll get to a little bit later, which is in J2objc, you're not running in a simulated environment. You literally have Objective-C, so you have Objective-C memory rules. So it's not garbage collected. It is reference counted. And if you have cyclical references, you have to like learn how to deal with that in your Java code. And RxJava seems like if there was a contest to write as many cyclical references as possible, they would have absolutely won. So that's still to be worked on. Like that needs some work. I wouldn't use it in a production thing. Event Bus, 100%. My DBORM passes 100% unit tests. Green.io and Covered, I don't remember. And the rest of them, ish, whatever. But it's important because you're taking Java code and moving it to an entirely different environment. So the unit tests are important to run. They become less of an issue as J2objc becomes like more completely stable in every environment. Like the JSON unit test effort, it started passing around 95%, and to get it to almost 100, there were actually a few fixes we had to contribute back to J2objc in reflection land just to make sure it was like, there were things that weren't working properly. So as time goes on, I don't think it's going to be as much of an issue, but now you absolutely should be running your unit tests against your code. Anyway, basic usage. You create a standard Java module within your Android project. So instead of having one module, you take your non-UI code, move it into a standard Java module, and then you add Doppl parallel libraries as dependencies in Gradle. So if you have retrofit in your project for Java, there's a retrofit Doppl library that is a tested and verified version of retrofit that runs in Objective-C. And that's like, if there's anything about this, the two real things to take away are tools to make it easier, libraries that you can use that you would use in your normal projects. Those are the two things that this really is about. So you add that, you point your iOS project, point to your iOS project, and there's a CocoaPods file, which future we'll get into why CocoaPods may not be the thing. And then you run the translation. And the basic goals are shared business logic. Everything below the UI and platform-specific stuff is shared. So there are no content providers or services in Doppl because those things don't make sense in iOS. But that's a different discussion. minimal impact on Android development time and Android platform risk, which didn't make it into the slide. And we've been evolving the message over time. And the whole idea basically is you can build your Android app without having anything specific to J2objc or cross-platform in it. It is a 100% normal Android app, and it should be no real impact on your Android development time. That's like the critical thing to take away from this, and that's what makes this different than other things. So why Doppl? Shared logic, whatever. But first, some assumptions. This gets into it. Your UI should be native because shared UIs are generally bad. If you don't believe that, then this talk is going to be a waste of your time. And I found that as much as I try to convince people of that, until they release a shared UI application and go through the pain of dealing with that, they don't believe it. That's it, right? And the fastest way to build something is its native platform. By that, I mean, if you were going to build a thing that was only launching on iPad, like a kiosk app, and someone tried to convince you to build it in HTML5 instead of Xcode, and you had availability of either resource, they'd be crazy, because it's just faster to build it with a native thing for that platform. Which platform takes less time to build for? We're at an Android conference, so people will guess one thing, but it's a trick question. The second platform takes less time to build for because the first platform in any normal product development lifecycle is going to take a lot of time when you're learning your lessons, right? So let's say this is your super abstract representation of building an app, and the end here is your V1. There's never really an end when you're building a product, right? But we'll just call this arbitrarily that. And resources is just, let's say, whatever. The second platform is like this, because the rest of that time in that first thing is all due to, changing what you're building. Maybe you're adding screens, you're changing screens, you're throwing screens away, so you're learning lessons. It's dealing with your server API and changes because the performance isn't right, yada, yada. And if you've ever worked at a startup, this is conservative, really conservative of the amount of time that the first run of your product will take. And if anybody thinks that's untrue, then you haven't really worked at a startup that's, done a few iterations, right? Your second platform does not have to learn those lessons unless you, okay, so anyway, it's waste, right? We call it waste, but it's really valuable lessons that you have to learn when you're building something, right? And two platforms don't cost 2x. That's like the thing when people argue about building native. They're like, well, I don't want to build it twice. It's going to cost twice as much, and it's not. Unless you build them both at the same time and you don't learn those lessons, which some people do, and that's crazy. So, foreign development's always slower. And yes, if I was talking to someone at Microsoft who was pitching Xamarin, they would argue that that's not true. But if you've ever used Xamarin Studio and you've tried to use the libraries that are in Xamarin, which is a much smaller library ecosystem, and you've tried to build, let's say, an iOS app and try to take the storyboard thing from Xcode and wire it somehow into your Xamarin things, it is slower. If you're building an HTML5 app, it's significantly slower. I know React people love React, but it's just slower. It's just the tools are not set up for this. It just takes more time, right? So the hashed lines here are the extra time it would take to build the equivalent thing. So the point here, all devs takes longer. Tools, libraries are far more mature. There's much less of a community, so you can't get support. The debugging and monitoring tools aren't as good. The screens, especially in something like React, are lowest common denominator. So, you have to have something that's going to work on both platforms and have the weird layout things, yada yada. So your costs are multiplied. And to go back, and there's no chart that expresses this, but you have to remember not just your costs of building, but all that waste, quote unquote, your lessons learned, they're also more expensive to learn. And that's the part of the discussion that's missed, right? So Doppel's goal essentially is your first development time is basically unaffected, and then the second platform, you're really just adding the screens on instead of doing all replicating the business logic and whatever. That is the goal. And yes, again, if I was having a debate with a Microsoft person about Xamarin, I'm sure that they would be like, oh, that's garbage, and yeah, whatever. But I'm the one speaking, so that's that. Anyway, it's probably more like this, or maybe even worse, especially now because it's new, but that's what the goal is. So, key points. Java Android development time should be relatively unaffected and Android Studio is the fastest way to do it. UI design is in wire as Xcode. You wire the things in. You can use Swift or Objective-C in your logic in the Xcode too, which is kind of important. You want to keep as much logic as possible in shared code and keep UI as dumb. So a few things here that did not make it into these slides, but 2 points. Number one, if in most cross-platform things you are doing a simulated environment that gets pushed out to both platforms, right? But let's be honest, in Android, there's a lot more risk of fragmentation. We're currently supporting, if you're building an app, like we support version 4 up through now version 7. So like that's your spread of major version numbers. You got devices from all over the map, screen sizes, all kinds of things. And then you got, manufacturer-specific crap, all this kind of stuff going on. iOS, it's like, yeah, you have this handful of devices, probably one version. So if you're going to pick one platform to not do in some weird simulated environment, I would argue that the risk surface is much better spread to go only on iOS. Everything using this in Android is 100% Android using 100% Android tools. So that's one point it's kind of hard to explain. I think only this kind of audience will actually understand it. I tried to explain it to a general dev audience, and they were just like, at this point, going to get more drinks. The conversation was over. And, oh my God, I had another point, which is completely lost on me. I explained that one too hard. So, that's not important. If it comes back to me, I will. It dovetails with the model view blank discussions going on. So model view presenter or whatever. The whole idea is to get your model and your logic separate from your view, so they're easily testable. And this architecture depends on that and facilitates that significantly. So you can write your logic and your models and your networking and your threading and everything in a shared library, and write your unit tests that hit that and test the crap out of it, and you can run those on both platforms, and then you just wire your UI into it. So that's like, I think it dovetails well with what we can maybe currently consider best practice. So point to make a slide. Don't forget risk, blah, blah, blah. If you're using some weird environment and you're just, all the way to about to release, like we had a client briefly that built the whole thing in Titanium Accelerator, and they're like, we have to release like next week, and this thing just doesn't work. Like, what do? Do you start over? Do you write the thing over? Do you have to like create some weird like side patch, all this kind of stuff? And they had a nightmare. We had to like fix it for them. Debugging is more difficult, especially if you're using a third-party language and whatever. So you're going to have, crash reporting and non-native tools and all this kind of stuff. What if Apple's just like, we're not going to let you release that? Like, what do? You're kind of screwed. Now, a lot of this is FUD, to be fair. Like, I don't think Apple's really going to be that draconian, but who knows? We have a funny story about the Droidcon app, which has an iOS portion built with this thing that they rejected, and I'll tell you why. What happens if the platform support drops off? Who knows? Like, Accelerator might go away. What happens to people that work at React at Facebook? Just, like, go to another company and nobody really gives a shit anymore? Like, who knows? So, that kind of thing. And then there's less risk here. Java, Objective-C aren't going anywhere. I mean, they're actually sort of especially Objective-C is the boring, forgotten part of Apple's stack, but they're certainly not removing it. You can use native tools, and frankly, if you're in Objective-C and something in your shared code is not working, it's a native platform in a native environment. You can just code around it. So your risk is significantly reduced. Your worst case parachute is not like a big deal. So that's kind of the thing. And performance is pretty good. I'll get to that in a second. So use it if you've got a lot of business logic. You don't absolutely have to launch on iOS first, obviously. Don't use most own content. If you have a lot of content, no logic, it's not really useful. Heavy UI. If you don't want to deal with build issues, and there's some you can imagine. And iOS devs I talk to generally are very vomity about this whole concept. So you pretty much have to be able to force them to use it. So status, we're using it internally. We are working on projects that we're going to release soon. Nothing really public I can talk about so much, except the Droidcon NYC iOS app, which is an interesting story. It is functional, but brittle, and I mean the tools are brittle. The libraries that are well tested are not. So we actually have some pretty good performance out of it. Works in tests, reviewing memory cycles. That's something you just have to learn, is to understand memory cycle issue, and there are annotations supporting that, and Sometimes you have to massage code. It's usually not that big of a deal again, except like RX is kind of a mess. It's not. RX itself is not a mess. RX in the context of Objective-C and memory cycles is. Let me clarify. So public launch, hopefully Droidcon-ish, late September. That has been crossed out. We've had a whole bunch of other business stuff happening that has kind of made this delayed. And then all of a sudden, we're like, oh, wait, yeah, we're going to talk about that thing. So I didn't even finish the slides, much less finish the platform. So it's coming, though. We want to get away from, right now there's static libraries, and I want to get more into actually packaging them as frameworks in the Xcode sense. If you don't know what that is, whatever. And it's the Gradle tool. The Gradle tool is forked from J2objc Gradle. There are a number of issues. Number one, it uses the native build lifecycle thing, and that requires Gradle 2.8. So now it's stuck at 2.8, even though Android is significantly further than that, which is frustrating. And the native build stuff in Gradle is tied to the build lifecycle step. So anytime you change anything to shared code, it triggers a recompile and rebuild of the iOS stuff. And really, that's not how you would work. You build for a while on Android, then you say port, and you go to the other thing. So it is slowing down today your build cycle time. So the first thing on the list is redoing the Gradle plugin. It's super important. Yeah, their memory cycle tools, they have a cycle finder tool, but it just analyzes the source and suggests where there may be cycles. It obviously can't figure that out for you. And it's very cryptic to read. It's built for like super ninja programming people who probably understand parsing tools. There's probably low-hanging fruit in building it into Android Studio in some way that would be helpful. Because frankly, if you're building an app with this tool, your goal is not perfection. It is to get something out really fast and then spend time iterating on it. So you really should be focused on low-hanging fruit. If you have a little bit of memory leaks here and there, it's probably not going to kill your app. Also, Apple has excellent tools on the other side, so it's more of a training issue. But anyway, the future, that's where that's going. And more libraries and fixing the libraries and that kind of stuff. Setup and usage again, you just make a Java library, make a Java library that's not really anything special, and you put your non-UI logic into it. So for the Droidcon app, that means our database libraries, our networking libraries, our syncing libraries, presenters for the views, threading, everything that wasn't related to the UI went into the shared thing. Add Gradle plugin dependency. So we have normal Android dependencies, and in the bottom we have a Doppl specific dependency scope, I think, and then Doppl specific dependencies, and all of these have an extra number at the end of them because they also have their different releases. And a lot of the changes in Doppl have more to do with memory cycles and testing than they do with actually changing any of the code. That's just an FYI. So, yeah, that's step 2. And then you add some config. We just point out where your iOS project is. This second thing is going away. I think it's already gone. The names that get translated out of these things are verbose, so you can shorten them up. So if you need to see this package, you can do this prefix instead of some big long prefix, right? And final configure is just some weird thing. Again, we have to change that Gradle project because it is not great. And add config pod file, iOS project, and then you just essentially from your UI logic call the same method, which is this is Android, that's iOS, and they do the same thing. So again, presenters, if you know what the presenter thing is, you set that up in common code, and your view is like a host interface, you pass that in. Unit test the same. Again, thing I talked about before, which I forgot the slide was in there, so I didn't need to especially talk about it much earlier in the talk, but whatever. And why Doppl? Short for doppelganger. We dropped the E because a lot of Doppls are trademarked. Performance. If you know me, I write a lot of database stuff. So I gave a talk about databases at London last year, where I had a benchmark where I compared a bunch of ORMs. And I can show you right now if you want to see it, but iOS running Android database libraries with this benchmark generally outperforms the Android phone. So that doesn't mean that everything's faster, doesn't mean everything's better, but it does certainly, implies that performance is not what you would normally expect in a simulated environment. Although if you use Xamarin, to be fair, Xamarin's actually pretty fast too. But certainly other things like whatever that Rails to iOS freaking thing is, like apparently the performance is nightmarish and terrible. So cool. That's the public info, which I should have adjusted because we have built the iOS app for the conference with this. But the iOS app for the conference is pretty aggressive and has a lot of third-party things you have to sign up for, right? So what we wound up doing is taking that and stripping out the third-party stuff so you could build an iOS app for the conference that doesn't require all these crazy things. So you can get this, and it goes through the steps of setting it up. There are a number of steps, just FYI. Again, it's not a polished framework, but you can actually get this, run it, and see how it would work. And if you use those exact same libraries, you could actually build something with this. I will give you a quick demonstration of this, but in Android Studio, you'll see here, I guess this is a presenter mode. You probably can't see that at all, right? But it's not super important. This whole thing is the shared code. So we've got our database ORM code. We got our network code for JSON to build these objects for the network stuff, DAO objects, that kind of thing. Our retrofit code, presenter code, which all the UIs call and does, they do a lot of logic. And then we have this threading code, which uses a task queue, including a persisted task queue that we wrote, and all this stuff is a logic that gets off the UI thread, then a bunch of util stuff. All this lives on the iOS side as well after the porting, and that's essentially how you do how you share the code. So once you run this thing, which succeeded, thankfully, we get the Droidcon OSC. Now, Apple rejected the submission of the app not because there was any issue with the logic or the code or the platform. They rejected it because there was a little Android guy behind this little dog. Okay, so we put out a version. We're still waiting for the full release, but they've tentatively released a testing version with this dog in it, which I submitted as a joke, but they're actually accepting it, which is nuts. And every instance of Android I've replaced with sad puppy, so including in the text. So this is the Android version, or this iOS version of the code, and everywhere it says Android, it says sad puppy, right? But under the hood, this list, everything that's in here, I didn't put who does not have the Android app installed? Okay, so if you haven't seen the Android app, but this list, all the stuff, all the syncing, all the data storage, everything is shared code and unmodified Android shared code. That's the point of the framework, right? You click on this thing, and again, when you click, I want to go to this talk, that's all shared code. That's all the same stuff, the database, everything, logic under the hood. The only thing that's specific to iOS is the UI. Now, to be fair, if you've ever built a significant mobile app, is a lot of your time spent on UI code? Yeah, a ton of it is. But frankly, so is in the logic if you have a significant amount of business logic. And our app should work totally offline, although I found out if you put it in airplane mode and you turn on the Android app, it will crash, but that's probably something weird. Anyway, if you fixed that one little thing, it would work fine. That's what all these persisted task queues and all this stuff's about. So that's it. I mean, it's all the same logic, and that's how this works. I would run through the steps of changing something and then compiling it and showing it to you, but you're just going to have to accept that what I'm saying is true. And if you want to go get the code and run it yourself, you can do that today. Just got to, message me for the URL because I could put it up here, but you'll probably forget, right? So it's in GitHub. Here. So if you go get this, it'll walk you through the steps of setting it up, running it, and then you can see how it works. We're going to keep working on this. I want to have some sort of release. The problem I have is, how do you make this into a thing that, do people actually want this? And are people going to use it? And is there a product you can make out of it? And I don't know. but this has been my personal like fixation for about 6 months. So here you go, world. It is your thing. So that's it. Questions? Yes. We went to a bar before this talk, so I normally would not be able to help you. I can even less so now. So, so frankly, I got nothing for you, but probably not. Probably not yet. Yeah. There you go. Yeah.
And so you were mentioning Gradle support.
Well, we forked a Gradle plugin for J2objc. That project has since been completely abandoned. I took a bunch out of their Gradle project. I also disagreed. Like they had a thing, which is sort of in the middle of J2objc too, where like if you have a dependency, it can try to get the source jar and automatically transpile that for you. But like that's a nightmare. You really need to have. That's why the libraries need to be vetted. Like you need to have unit tests run against them. Like retrofit is very close to what retrofit normally be, except we had to remove the Apache client, remove the OKHTTP client, and then there's like, one little thing in there that does the main thread executor. It actually dives into Objective-C to do the threading stuff, so the background and then foreground thread. It's not very complicated, but you have to do stuff. In JSON, there's a couple places where there are going to be memory leaks, and you have to go in and deal with them. So that Gradle project's abandoned. Ours is not, but it's based off of old Gradle, and we need to like redo it, essentially. So, yeah. Swift Package Manager, no. Carthage, yes. So just building normal frameworks. It is used for, very simply, the libraries. So if you look, this is automatically generated. The library, the shared code in this thing, really, it's not going to make this bigger? That's terrible. The shared code for this project is here. The rest of these are all the dependencies. And they just point at the dependencies that are being used inside this thing. And it's a long story, but it's just being used, and it was being traditionally used by the Gradle project initially. So I don't like super dislike pods, but it's at best tolerated by Xcode and Apple. So I don't think it's a long-term solution, and I think frameworks are much more portable. I think that because that's what everyone says. I don't know if it's true. So, yes. All right, that's it. That's all I got. Thanks. Woohoo. Yeah, sure. To be honest, the folks that wrote the Java to Objective-C, like they really did the computer science-y heavy lifting here. So people ask, like, why don't you go the other way? I'm like, well, because that's the tool that exists. So unless we like raised money and built like a business out of it, I don't see it happening. But it doesn't convert to Swift, but your code can be Swift that calls it. So it reduces the necessity. I think if there was anything, it would be more the other way around, like taking Objective-C to Java like that, because then you get like a fully backwards thing. But I think, frankly, that's more important in 2012. 2016, although startups and a lot of companies will start in iOS, it is not like what it used to be, where it was like absolutely true. We've been talking about this for a long time, that what platform you're on, it's not as critical that you start on iPhone. You know what I mean? So it's like kind of a thing. But yeah, if you're going to code in Swift, you can totally use Swift. Actually, the Droidcon app is like the weirdest stew of technologies you're going to see, because we have Kotlin, Java, Swift, Objective-C, Firebase, Crashlytics, Zendesk. Like any of the sponsors of the SDK are kind of in there. Like it's a mess. It's like absolutely a mess. So you can see where it can actually function well in that environment and still sort of satisfy needs. But yeah, so No, is the answer. But that's why. I can't even imagine the alternate reality where Apple just is like Objective-C's done. Even if everybody that was a longtime Apple developer decided they hated the Objective-C, which I imagine internally is probably kind of the opposite. You know what I mean? Like it would be amazing if Apple did that. Let me see. What do you call? What is the name of the iTunes Connect? Let's actually see if they finally released this app. We've been waiting for days while we're talking here. But yeah, I can't imagine them. But you know, honestly, if they did that, this framework would be like the least of everybody's worries, right? It'd be like the end times if Objective-C just got, you know. That. Well, no, people. Oh my God, it's live! Woo! They approved the ridiculous joke. Yeah. No, it's live in the App Store. Everyone look for it. Droidcon NYC. Sad puppy. Actually, it's like Godfrey Nolan, if he's watching. Your talk I wanted to pick. He was going to show you actually using Swift on Android, but like the idea that somebody's going to port that, the rumors are greatly exaggerated, and the thing that's for real, because it's not like, oh, all of a sudden you can just do this cross-platform stuff. Like none of the libraries, like, you know, retrofit doesn't work, you know, and then the libraries for iOS are not going to work on Android. It's just a language that would be ported. So there's a whole missing ecosystem, you know, and that's like Go works on Android. Does anybody use it? Of course not. You know, like Scala. Well, more people use Scala, to be fair, and it's JVM compatible, so it's like you could use it, but like Swift kind of wouldn't be, I assume, right? So it would be like Xamarin. I like Xamarin in concept, but there was only one database ORM library that exists for it, and it was like some development shop in the Midwest came up with it, and it's like, well, I'm sure it has major shortcomings, but that's your only choice. That's part of why it's like slower to develop in these kind of environments, because you have no options. So, you know, anyway, yeah.
Do you guys do any
No, that's good. It's a good thing, and that's, you know, so part of this is like when you start the project, we have interfaces that you get passed into the from the native into the thing. So it's like get string, and it does the native thing. If this became a product, that would definitely be one of the things that would happen. So, yeah, cool. All right, guys. Thank you. All right.